Good afternoon, class. We are looking at section 1.6, sequences and difference equations. We start with the summary. A sequence is a list of numbers written in a specific order, a sub 1, a sub 2, a sub n. Here's the first, here's the second term, and here's the nth term of the sequence. A sub n is the general term, and n is the set of positive numbers. Recursive sequence, also known as difference equation. The next term depends on knowing the previous one or previous ones. A sub n plus 1 is f of a sub n. An arithmetic sequence. We're going to look at the arithmetic and geometric sequences. You hopefully remember it from algebra. It starts with a term and then we add a constant, addition or subtraction. Remember, subtraction is a form of addition. So a sub 1, a sub 1 plus d, a sub 1 plus 2d, and the general term, a sub 1 plus n minus 1 times d. Now we can define this either recursively, that means a sub n plus 1 is a sub n plus a constant d, or explicitly. A sub n equals a sub 1 plus n minus 1 times d. An example here, 15913. As you can see here, we are adding a constant of 4. We are adding number 4. Therefore, these 4 here. A geometric sequence, a sub 1, a sub 1 times r, we're going to multiply by a constant, which is called the ratio. The next one would be a sub 1 r squared, and here's the general term, a sub 1 r to the power of n minus 1. And we can define it either recursively, which means a sub n plus 1. The next term is r times the previous one, a sub n. Or we can do it explicitly. A sub n is what we just said here, a sub 1 r to the power of n minus 1. Here's an example. R is 4 here. We are multiplying by 4. So 1 times 4 is 4, 4 times 4 is 16, 4 times 16 is 64. And 4 times 64 is 256, so on and so forth. Arithmetic sequence, geometric sequence. Let's recap the definitions with a little bit more details. A sequence is a list of numbers, as it was mentioned, written in a specific order. Measurements collected at discrete time points and quantities that undergo periodic changes, such as annual plant or insect populations, are studied using the concept of sequences or the data and difference equations, the description of the mechanism of change. So a sequence is a real valued function f whose domain is the set of natural numbers or positive integers 1, 2, 3, and it continues indefinitely to infinity. We use the notation a sub n to denote f of n, a sub 1, a sub 2, all the way to a sub n. Here's the first term, a sub 1, here's the second term, a sub 2, and here's the general term, a sub n. Let's look at some examples. We're going to start with a very simple example. Part A sub n is n, and we are interested in finding the first 5 terms. So simply put, start with 1, replace the n with 1. So if n is 1, that means a sub 1 is 1. If n is 2, that means a sub 2 is 2, right? And so simply put, the first 5 terms are 1, 2, 3, 4, 5. What about here? The same thing. We want the first 5 terms. We're going to replace the n with 1, 2, 3, 4, and 5. When we do that, when n is 2, 2 pi over 2 makes it pi. When n is 4, 4 pi over 2 makes it 2 pi. And we need to know the functional value, the trigonometric functions. These are common arcs, the common arc of pi over 2 or pi over 3 pi over 2. And for example, sine of pi over 2 is 1, sine of pi is 0, so on and so forth. And to help you remember this, I'm going to go over the basic trigonometric functions that you're supposed to know. So I'm going to remind you of what we call a unit circle. As you recall, a circle centered at 0, 0 has the formula x squared plus y squared equals r squared. When the radius is 1, it's called the unit circle. So this has coordinates 1, 0. If this is theta, let me just rewrite this. This has coordinates x, comma y, where x is cosine theta and y is sine theta. I hope everybody remembers that. Therefore, cosine of 0 is 1 because the angle is 0. Sine of 0 is 0. If you look at this point, which has coordinates 0, 1, this is pi over 2 or 90 degrees. So cosine of pi over 2 or 90 degrees is 0. Sine of pi over 2 or 90 degrees is 1. This point has coordinates negative 1, 0. And this is 180 degrees or pi. Cosine of pi is negative 1. Sine of pi is 0. This point has coordinates 0, negative 1. This is 270 degrees or 3 pi over 2. Cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is negative 1. So knowing the unit circle, it will help us with common arcs. And that's how we arrive at those answers: 1, 0, negative 1, 0, 1. how we get to those answers. All right, we're gonna clear the page and move on with new questions. The next one, C sub n is n over 1 plus n. Simply put, replace the n with 1. So C sub 1 becomes 1 over 1 plus 1, meaning 1/2. Replace the n with 2. So C sub 2 becomes 2 over 1 plus 2, which means 2/3. And we have the first 5 terms. In this case, we are interested in the digit in the nth decimal place of pi. First and foremost, pi is not equal to 3.14. It is approximated by that. Rather, it's 3.14159, and it continues indefinitely. And with that being the case, we want the first 5 terms. It's the nth decimal. The first one is 1, 4 is the second one, 1 is the third one, so on and so forth. So the first 5 terms of D sub n, which means the nth decimal, are as follows. All right. The general term of a sequence a sub n equals 2 to the power of n minus 4 is given, and we want to find the first 5 terms. So for example, if I want the first one, I replace the n with 1. So I get a sub 1 is 2 to the power of 1, which is 2 minus 4, and that makes it negative 2. What if I want the second one? So a sub 2 is 2 squared, which is 4, minus 4 makes it 0. If I want the third one, a sub 3 is 2 cubed, which is 8, minus 4 makes it 4, and we can easily see the rest. It is important to be able to show work for the first few, and then we can write the rest of it. All right, we want to find the formula for the general term a sub n, and it may not be easy. Sometimes it's a little bit more complicated, but we look at cases that are doable. And all you have to do is just follow the pattern and see what you notice. If we look at part A, what do we notice? Anybody? Do we notice anything here?
Goes by 3.
Beautiful. You may notice that we are adding a constant of 3, which means because we are adding a constant, it is an arithmetic sequence with the d or difference of 3. So this is the value of d. And we use the general form a sub n equals a sub of 1 plus n minus 1 times d, or d times n minus 1 makes no difference. Where a sub 1 equals 5 and d is 3, we're going to put it in. We're going to distribute number 3. And then we're going to combine 5 and negative 3. And the final answer is 3n plus 2. Now, here's the interesting part. Whenever you're done, you really should check your work. The way it works, it's very simple. If n is 1, replace the n with 1. Do you get the first term 5? Replace the n with 2. Do you get the second term, which is 8? That's all you have to do. Check the first few, the third one, the fourth one, to make sure this is the correct general term. Part B. What do we notice? Anything?
It's multiplied by -3.
Negative? It's being multiplied by negative 1/3. The common ratio is negative 1/3, and this is a geometric sequence. GS, short for geometric sequence. And the way it works, you can divide the second term by the first term, divide the third term by the second term, so on and so forth. And they all must be the same for you to claim this is a geometric sequence, and it's negative 1/3. So we go with the general formula a sub n equals a sub 1 r to the power of n minus 1. We replace the a sub 1 with 1 and r with negative 1/3. What I want you to pay attention to is that this one basically has no bearing. Anytime we have a negative sign, which refers to a case like this known as alternating sign, okay, it changes from positive to negative or vice versa, you want to separate the negative one. So in this parenthesis, if I take the negative one and separate it from the other part, which is 1/3, it's negative 1 to the power of the same exponent n minus 1. And in general, for any alternating sign, we either start with negative 1 to the power of n or negative 1 to the power of n minus 1. Note, the first term has a positive sign. If you replace the n with 1 here, you get a negative sign. Whereas here, 1 minus 1 makes it 0. Negative 1 to the power of 0 is positive 1. In some instances, they may use n plus 1 because it gives you the same result. Either way is fine. So pay attention to whatever your general solution is. Replace the n with 1, make sure you get the first term. Replace the n with 2, make sure you get to the second term, and so on and so forth. Again, the definition we have seen before with a little bit more detailed. Sequences are sometimes created recursively, specifying the next term given the present term. The initial term of the sequence must also be specified. This procedure defines each new term as a function of the previous one, and it may not always be possible to determine the general term of the sequence algebraically. A difference equation, also known as recursive sequence, is an equation of the form a sub n plus 1 equals f of a sub n, where a sub 1 is given and f is a real valued function. A solution is a sequence a sub 1, a sub 2, all the way to a sub n, satisfying the given difference equation. So that's the proper definition for the difference equation or a recursive sequence. One of those sequences that we have seen in algebra is called a Fibonacci sequence, where we start with number 1. The next one is also number 1. And then the next term, we add the previous 2. For example, here, 1 and 1 gives us 2. Now 1 and 2 gives us 3. 2 and 3 gives us 5, so on and so forth. So if I'm interested in finding the next one, what is my next term? All I have to do, add these two numbers. And my next term becomes 34. 21 and 13, they add up to 34. If I want the next term, I need to add these two. $55. Example in nature, it happens a lot. For example, the number of branches increases up a tree trunk according to the Fibonacci sequence. So we start with 1, and the next year we have 1, and the following year we add those 2, we get 2. The following year we add these 2, we get 3. And the following year we add these two numbers, we get 5, so on and so forth. Let's look at more examples. So we want to find the first 6 terms of the recursive sequence. The first one says a sub 1 is given. The number is given as 6. And a sub n plus 1 is a sub n over n, meaning if I want the next term, I look at the previous one and I divide by n. So to make sure we understand what's going on here, we have a sub 1, so the next one would be a sub 2. So this is 2. So a sub 2. You have two choices. You can say the one before that is 1, so it's a sub 1 divided by 1. Or you can set n plus 1 equals 2. If you set this one equals 2, and you solve for n becomes 1. So a sub 2 is a sub 1 over 1, 6 over 1. The next one is a sub 3. I want to make sure we understand this. So if now this number is 3, then n becomes 2, right? The one before that. We want a sub 3, which is equal to a sub 2 divided by 2. A sub 2 divided by 2. So we have a sub 2. 6 divided by 2, we get 3. Just in case, can anybody tell us what is the formula for a sub 4? So how would you write the formula for a sub 4? The numerator should be what? Anybody?
A sub 3.
Perfect. Divided by?
3.
Perfect. And the answer is 1. Again, as long as you can show a couple of items, a couple of steps, then the rest follows, and that's good enough. You don't have to write all the steps. So we did this one, this one, this one, and now we write the whole thing. If anyone has any problem with that, you want to go back and try this on your own. Here's the next example. We are given the first term, a sub 1 equals 1. We are given the second term, a sub 2 equals 2. And we are saying a sub n plus 2 equals a sub n plus 1 plus 2 a sub n, meaning if I want a term, any term I'm interested in, I get the previous one. See, this is n plus 2, this is n plus 1. And then the one prior to that times 2, and we add them up. if we understand this, then all we have to do, we have a sub 1 and a sub 2. Let's write the formula for a sub 3. So using that, and again, if you have any doubts, you can even set this one equal to 3 because that's the next term. So a sub 3. If you do that, n plus 2 is 3, n becomes 1. If you do that, n becomes 1. So if n is 1, this is a sub 2, and this is a sub 1. So a sub 3 is a sub 2 plus 2a sub 1. A sub 3 is a sub 2 plus 2a sub 1, according to the general term. So replace the a sub 2 with number 2 plus 2 times, replace the a sub 1 with number 1, and we get the total of 4. We're going to do one more. We're going to look at a sub 4. Can anybody share with us the answer for a sub 4? What would be the formula for a sub 4? Anybody? How would you write a sub 4? A sub 4 equals, remember this number is becoming 4, so n becomes 2. So if you change this to 4, if this becomes 4, n becomes 2. So this is 2. 2 plus 1 is 3. So a sub 4 is a sub 3 plus 2 a sub 2. So a sub 3 is 4 plus 2 times a sub 2, which is 2, and the total of 8. Just to make sure we are in good shape. How would you write this for a sub 5? Anyone? What is a sub 5 equal to, according to this general form? A sub 5. Anyone? A sub 5 see, this says whatever this number is, you go down by 1, so it becomes a sub 4 plus 2, and you go one more down, 2a sub 3. That's the formula. And so you plug in, you get a sub 5, a sub 6, and you write all of it. All right. So you want to work on this to get into good shape. As far as the last one on this page is concerned, a sub n plus 1 is 2, a sub n minus 4, and a sub 1 is 3. Therefore, the next one must be a sub 2. So according to this formula, what is the formula for a sub 2? If this is 2, n becomes 1. So a sub 2 is 2a sub 1 minus 4. A sub 2 is 2a sub 1 minus 4. Please understand what this tells us. It says if you want any term, multiply the previous one by 2 and subtract 4. So I want a sub 2. The previous one is a sub 1. I'm going to multiply by 2 and subtract 4. I get 2. I want the next one. I want a sub 3. So I want to go with this formula. A sub 3 is 2 times the previous one. That means 2 times a sub 2 minus 4. 2 times a sub 2 minus 4. And a sub 2, we have it here. You have to plug it in. 2 times 2 minus 4 becomes 0. And you can do the rest of them. I highly recommend you practice with the rest of them to make sure you can come up with the answer and start with formulas. All right. Example 5, suppose C sub T is the concentration of a drug in the bloodstream at time T. A, the inflow, is the concentration of the drug that is administered at each time step. I want to make sure everybody understands the meaning of time step when we are dealing with drugs and patients and medications. Every hour, every 5 hours, every 10 hours, every day, every week, they receive some sort of a medication. Maybe it's the pain medication, maybe it's the blood pressure, maybe it's diabetes, some kind of a medication. And the time step is the time that we repeat the same thing. And K is the fraction, portion, percentage of the drug metabolized or absorbed in a time step. The part that is gone, the body takes it and uses it. So I want to stick with part A only for now. What is the recursion that models the dynamics of drug concentration? Okay. So what happens is that the dynamics, generally speaking, we go with N, and in this case, I'm going to go with C in a moment, but N sub T plus 1 is the previous one, N sub T. That's the concept of a time step. And what comes in the inflow and what comes out the outflow. So this is the general form. I hope it makes a perfect sense to everybody. So anytime we want to calculate the new amount, we go with the old or original amount. And then whatever we add and whatever is out, what is out? This is the portion, the fraction, the percentage that was used and absorbed by the body. Now, because the next part gives us C sub 0, which I'm going to discuss in a moment, I'm going to replace the capital N with capital C. Okay, so this becomes C because of part B. The inflow, we call it A, and the outflow. K is the fraction of the drug that is absorbed. If 10% is absorbed, 90% is left. If 20% is absorbed, 80% is left, so on and so forth. So this basically is K, whatever this fraction or percentage is, times the original amount, which was N sub T. And of course, we are changing the N to C. So C sub T plus 1 is C sub T plus A minus K C sub T. Now, if we combine these two by factoring the C sub T out, we get C sub T times 1 minus K. And this is the general formula. So let's quickly recap and understand that. At the next step, we have whatever we had in the beginning, the previous step, times 1 minus K, because K is the percentage or portion or fraction which is absorbed. 1 minus that, the complementary event is left. So again, if 70% is K, 30% is left, 1 minus that. And A is the amount that we are going to constantly add at every time step, which is again, so many hours or so many days. It's a unit of time. And so in part B, let us write what is given. In part B says C sub 0, initially we have 120 micrograms per milliliter. And the amount of inflow is 80 micrograms per milliliter. And K, the portion, the percentage, the fraction which is gone and absorbed by the body is 1/2 or 50%. So let's plug in here. So this remains. This one we replace the K with 1/2. This one we replace the A with 80, and 1 minus 1/2 is 1/2. So 1/2 of C sub T plus 80. Now, C sub 0 is given. Let's go to the next one, C sub 1, and we are going to use this formula. So C sub T plus 1 is 1/2 C sub T plus 80. Therefore, C sub 1 is 1/2 C sub 0, which means 1/2 of this amount. 1/2 of 120 is 60, plus the amount of A or inflow, which is 80, and they add up to 140. The next one is C sub 2. This time is 1/2 C sub 1. So I want C sub 2. I'm going to replace the C sub 0 with C sub 1. Half of C sub 1. And C sub 1 is 140. What is half of that? 70. Plus 80, we get 150. One more. C sub 3 is half of the previous one, C sub 2, plus this constant A that we are adding, which is 80. So half of C sub 2 we calculated to be 150, which is 75. We add 80 and we get 155. Now, as t gets larger, C sub t goes to A over k, which is the sequence that converges. I want to explain this one quickly, and we will get to more details when we get to limits. The idea is that what happens if we keep on giving the same amount of medication to the patient, and we want to be careful with that. It will never ever go beyond this amount, which is a horizontal asymptote, and it can be calculated using A over K. So A over K, and we know the amount of A was 80. K is 1/2. 80 divided by 1/2 means 80 times 2. So 160 micrograms per milliliters, meaning it has been checked. It will never go beyond 160 micrograms, and it is safe for the patient. $160. Here's the last question we want to do. I want to ask someone to read this for us, if you don't mind. Could somebody read this example, please?
I can.
Please. Thanks, Emma.
Pacific salmon populations have discrete breeding styles in which they return from ocean to streams to reproduce and then die. This occurs every 1 to 5 years, depending on the species. Do you want me to continue?
Please.
Suppose that each fish must first survive predation by bears while swimming upstream, and predation occurs with probability D. After swimming upstream, each fish produces B offspring before dying. The stream is then stocked with M additional newly hatched fish before all fish then swim out to sea. What is the discrete time recursion for the population dynamics, assuming that there is no mortality while at sea? You should count the population immediately before the upstream journey.
Perfect. We do have a different scenario in part B, and then we want to compare it. So let's go over part A, and then we compare and contrast with part B to understand the concept. Let's go to the next page, and dissect the problem step by step. All right. So the number of fish we don't know, we can use any variable n sub t as time goes by. In the first place, you can say x, y, z. It doesn't matter. It is absolutely up to you. But n sub t. So let's read. Suppose that each fish must first survive predation by bears while swimming upstream, and predation occurs with the probability of d. That probability is always between 0 and 1. Can it be 0? Yes. Can it be 1? Yes. So 10%, 20%, 30%, whatever the case might be. So predation takes place with a percentage of d. So if 10%, for the sake of argument, are preyed upon, then the rest of them, that means 1 minus 10%, that means 90% will survive. Okay. So it is important to understand this very step, which is about predation. So n sub p, if we call it as predation, is n sub t minus d times n sub t. In other words, again, if d is 10%, that means 1 minus 10%, 90% of the original amount will survive. So that's predation. After swimming upstream, each fish produces B offspring. So each fish produces B offspring before dying. So basically, this number of fish get multiplied by B, and then normally we add that one also, but they will die because after swimming upstream, each fish produces B offspring before dying, so they will not survive themselves. So simply put, this step is being multiplied by however many offsprings B. So you have a choice of simply multiplying this one by B, or explain that n sub p, we're going to add B times n sub p and then minus n sub p, because those who were in the previous time step, they are all gone because they are going to what? Die. So simply put this number times B. This number times B. And then what happens? The stream is then stocked with M additional newly hatched fish before all fish then swim out to sea. So now we are adding how many? M. So we are adding M to this number. So finally, we are adding M. That's the number of fish we are going to add. So this is one way to deal with it. This is part A. Now, let's look at a slightly different scenario. Suppose that instead of preying on fish while they swim upstream, bears do so only while the fish are swimming downstream. What is the discrete time recursion for the population dynamics? Again, assume there is no mortality while at sea. Again, we have the certain amount n sub t or x or y or z, any variable of your choice. So each fish produces B offspring before dying. So there is no preying yet. First they go upstream and they give us B offspring. So simply put B times that. Or you can say n sub t plus B times that minus n sub t, because the original size that we have, which is n sub t, they will die. So simply put B times n sub t. Now we are going to add how many? M additional newly hatched fish. So we are going to add to this number M. And now at the end, all fish face predation with probability of D. So that means if 10% are gone, 90% is left. If 20% are preyed upon, 80% is left. So 1 minus this number, 1 minus d times this is what is left. So I hope you can see the difference between the two. And now we want to compare and contrast. Which of the recursions obtained in parts A and B predicts the largest increase in population size from 1 year to the next? Justify your answer both mathematically and in terms of the underlying biology. You can assume that D is between 0 and 1, B is larger than 0. D is the probability. Probability can be 0 or can be 1. But they are saying that there is some predation that takes place. And of course, B is the number of offsprings, which is positive. So remember, in part A, we ended up with this number at the end. B times 1 minus D times N sub T plus M. And in part B, we ended up with this number, 1 minus D times B times N sub T plus M. So which one gives us more fish? In this case, remember, what happens in the first case is that as they go upstreams, okay, while swimming upstreams, the predation takes place. Then they have B offsprings coming down and we add M. In this case, what happens? In this case, there is no predation going upstream. So they produce B offsprings and they die. Then we add M, and coming down, the predation takes place. So that's why we have two different formulas. That's important for everybody to understand. Which one do you think gives us more fish, the first or the second case? Any ideas? Well, again, this one, predation takes place as the fish go upstream. They provide B offsprings and we add M. In this case, it's the other way around. First, they go up, they hatch B offsprings, we add M amount is the number of fish that we add, and then the predation takes place. So 1 minus D is the percentage or fraction or a portion that survive. Mathematically speaking, we can just do part A minus part B, see whether it's positive or not, or vice versa. If part A minus part B is positive, that means we get more in part A. So let's write this in this fashion. And all you have to do, just do the math. Okay. So we are writing part A minus part B. So we can distribute if we want. We can keep this plus M, this one minus 1 times this. Okay. And then minus D times that. So we can write it in this fashion. Again, there are different ways of writing it. All you have to do is simplify this process. So this one you can keep it. This one is plus M. Then we have minus. If you multiply these two, see B, I put it here, times 1 minus D times N sub T. I hope you realize this is this part. And then 1 minus D times M gives us minus M plus MD. So we can see that everything cancels out. This one cancels this one. Positive M cancels this one. What do we end up with? The only thing left is MD. Please understand this is negative times negative makes it positive, okay, when you multiply by M and D. So that's how we get the MD. So the result is MD. MD is larger than 0. And because part A minus part B gives us a positive value, then part A gives us more fish. And it makes sense because part A, all the additional fish survive. Remember, in part A, we add so many fish at the end. None of them gets preyed upon. Whereas in part B, all fish face predation. And that's why part A produces more fish.